In the last lecture, we had an overview of network scanning. In this lecture, we will see the different network scanning techniques. So, let us start one by one. The first one is ICMP scanning, that is, checking for live systems. ICMP scanning, that is, Internet Control Message Protocol scanning, is used to check the live systems. Ping scan involves sending ICMP echo requests to a host. If the host is alive, it will return an ICMP echo reply. This scan is useful being active devices or determining if the ICMP is passing through a firewall. Ping sweep scanning. Ping sweep is used to determine the live host from a range of IP addresses by sending ICMP echo requests to multiple hosts. If a host is alive, it will return an ICMP echo reply. Attackers calculate subnet masks by using the subnet mask calculators to identify the number of hosts that are present in the subnet. Then, the next is ICMP echo scanning. In the real sense, this is not port scanning since ICMP does not have a port abstraction. However, it is sometimes useful in determining which hosts in the network is up by pinging them on. The next is TCP Connect, or it is also known as full open scan. The TCP Connect scan detects when a port is open after completing the three-way handshake. For example, if an attacker sends the first synchronization packet plus port number, and if the target replies with sync plus ACK packet, an attacker again sends ACK packet, then we can say that the target is open. Whereas, if attacker sends sync packet, and if the target replies with RST, that is a reset packet, then we can say that the host is down. TCP Connect scan does not require the super user privileges. The next is stealth scan, that is half open scan. The stealth scan involves resetting the TCP connection between the client and the server abruptly before completing the three-way handshake signals, hence making the connection half open. Attackers use stealth scanning techniques to bypass firewall rules, logging mechanism, and hide themselves as usual under network traffic. So if anyone asks you which scan we can use to bypass firewall, confidently you can answer stealth scan. What is the process of a stealth scan? First step is that the client sends a single sync packet to server, SYN, that is SYN packet. If the port is open, the server will respond with SYN ACK packet. If the server responds with RST packet, then the remote port is closed. Next is EXMA scanning. In EXMA scan, the attackers send a TCP frame to a remote device with finish, urgent, and push flags set. FIN scan works only with operating systems with RFC 793 based TCP implementation. Do not worry if you're not getting right now. We're going to see all these concepts in upcoming practical videos. Next is ACK flag probe scanning. Attackers send TCP probe packets with ACK flag, that is acknowledgement flag, set to a remote device and then analyzes the header information. The next is idle scanning. Every IP packet on the internet has a fragment identification number, that is IP ID. Operating system increases the IP ID for each packet sent, thus probing an IP ID, an attacker the number of packets sent after the last known. The working of IP ID is really difficult to understand. You need to at least have a look at it for 4 to 5 times and then you will get the working of IP ID. And the last one is UDP scanning. UDP scanning, there is no three-way handshake as it was in the case of TCP scanning. The system does not respond with the message when the port is open. So, if an attacker asks port by sending a packet, is port 29, that is UDP port open, and if the server does not reply, it means that the UDP port is open. So, let us have a quick recap. In this lecture, we studied different types of scanning techniques. It was a heavy lecture, I know, but do not worry. We will provide you with certain links and descriptions so that you can go and read if you want. In the next lecture, we will start actually scanning websites and networks.